Now, I'm going to take a different turn as compared to how many textbooks or all textbooks treat this. I'm going to start this by doing a little mathematical treatment of the general equation of any projectile motion. Now, remember, a projectile is any object such as this, or this, or this, whose motion is strictly under the control of gravity. Remember, gravity acts vertically downwards. That means that the object accelerates downwards and has no acceleration in the horizontal direction. And let me say that again. The reason the acceleration in the horizontal direction is zero is because there is no net force in the horizontal direction acting on the object. And the reason the object accelerates downwards is simply because the only force acting on the object is the force of gravity, which acts vertically downwards. So we know that 1, AX is equal to 0. We will take the upward direction to be positive. That means that AY is equal to negative G, simply because the upward direction is positive. If you recall from the kinematics equations of motion, because this is a two-dimensional motion, what you need to understand is we will analyze the X motion completely different from the Y motion. So I will draw a little table. I'm going to put here the horizontal motion, and I'm going to put here the vertical motion. So the equations that defines the horizontal motion you have here, Vx is equal to Vox plus Axt. You have Vy equal to Voy plus Ayt. You know, this adjusts the equations of motion for a uniformly accelerated motion. You have X equal to X naught plus Voxt plus 1/2 Axt squared. Similarly, you have Y equal to Y naught plus Voy t plus 1/2 Ay t squared. You have Vx squared equal to V naught X squared plus 2Ax delta X. Similarly, you have Vy squared equal to Vy naught squared plus 2Ay delta Y. These are the equations for the X motion and the equations for the Y motion. Because Ax is 0 implies that Vx is equal to Vox. This is critical and very important. This will also mean that X is equal to X naught plus V naught Xt. So this is the equation that defines the position of the object, that shows how it changes with time along the X direction. As you can clearly see, because the acceleration is 0 in the x direction, the speed and the velocity remain constant. Similarly, in the y direction, ay is equal to negative g. That would mean that vy is equal to voy minus gt. And that will also imply that y is equal to y naught plus voy t minus 1/2 g t squared. Clearly, what have you seen here? That the velocity in the y direction actually decreases. If we draw the graph, it will look like this. So if we draw the graph of, this is t, this is vx, it's gonna be a straight line. This is vox. It doesn't change simply because ax is 0. But if we draw the graph, this is t, this is vy, it will start somewhere here. This is voy, decreases to 0 at maximum height, and then increases in the negative direction. Keep in mind that this area is equal to this area. So the next thing for us to do is to derive the equation of motion of projection. So let's start here. We will do this. The equation of trajectory is a function, y is expressed as a function of x. This defines the equation of motion of a projectile. So for us to look for y as a function of x, that means that we need to substitute t. And that is not going to be a problem because x is equal to x naught plus v naught t. That would mean that t is going to be equal to x minus x naught divided by v or x. So if we take this expression and substitute it in here, we will end up with, by the way, let's assume that the object starts at the origin. That would mean that x naught is equal to y naught, which is equal to 0. So in that case, this is just going to be x divided by v o x. So that means that y will become equal to v o y bracket x divided by v o x minus 1/2 g bracket x divided by v o x all squared. So if we simplify, we will have y equal to v o y divided by v o x multiplied by x minus g